Hello, everybody. Today we're going to be reviewing four pretty commonly seen graphing problems that you might see in your AB calculus, BC calculus, or calculus semester 1 exam, AP exam, final, etc. So let's get into it. So the first problem is a graphing problem regarding average value. So this is pretty commonly seen, especially in AB and BC versions of AP Calculus in high school. So let's discuss this one right now. So the function f is continuous on the range of x equals -4 to x equals 4 inclusive, and the graph of f shown above has 5 line segments. So we need to find the average value of f on the interval where x equals -4 to x equals +4. So basically what this wants is the average value of x on this graph. So what is the average value? Well, basically, if we sum up all of the points on the graph, and we put them in like a list, and then we take the mean of that list, or the average. You guys should know how to do mean, like, or average. Mean and an average are the same thing. For example, if I have 1, 5, and 10, how do you take the average of that? You add them all together, so 16, and then you divide them by the number in the list, so 3, so 16/3. So in calculus, you're going to want to sum up all of the points on that graph. How do you do that? Integral. So given f of x on interval from x equals a to x equals b, if we want to find the average, we need to take the integral of f of x on that interval, and then we need to divide by the range of the interval. So that's pretty simple. First, we need to get the sum of all the points on that interval. So that's the integral of f of x dx on the range from a to b. And now we need to divide by the range of the interval. So we can do divided by, and so the length of the interval, or the range of the interval, is the distance between a and b. So, what that's going to be is this going to be the absolute value of b minus a. Yeah, so let's apply that here. We don't have a function f of x, but if we want to find the integral from a graph, basically the integral is the area under the curve. So for area under the curve above the x-axis, we add it. For area under the curve below the y-axis, below the x-axis, we subtract it. So what that means is we're going to take all of these areas and add them. And then we're going to subtract this area. So how are we going to get those areas? Well, this is a graph of lines. It's just a bunch of triangles and squares. You guys know how to do that. How do you get the area of a triangle? Well, it's 1/2 base times height. How do you get to the area of a square? Well, it's just going to be width times length. So let's sum up the triangles. We have a triangle right here. Base is 2, height is 1. 1/2, 2 times 1 is just equal to 1. Now we have another triangle here. Base is 1, 2, 3. Height is 2. 2 times 3 is 6, times 1/2 is 3. Now we have this weird thing where we have a triangle here, another triangle here, and then a square here. That's not a problem. So first, let's just sum them up. First, we have this triangle from 1 to 3. So the base is 2, the height is 2. So that's 4 equals base times height. Then we're going to divide it by 2. So that's 2. Then we have this triangle, which is just a 1 by 1 triangle. So 1 times 1 times 1/2 is 1/2. And then we have this square, which is a 1 by 1 square. 1 times 1 equals 1. So now we have the area of all the different segments. So now we've got to add together the ones on the top and subtract the ones on the bottom. So let's do that. 1 plus 2 equals 3, plus 1 equals 4, plus 1/2 equals to 4.5. So 4.5 on the top. And now we're going to subtract the bottom, which is 3. So 4.5 minus 3 equals 1.5. So this 1.5 is basically this thing, this integral. Now we need to divide it by the distance from b to a. So the absolute value of b minus a, in this case b is equal to 4 and a is equal to -4. What is 4 minus -4? That's 8. So we divide this by 8. So our answer, the average value, is 1.5 divided by 8. Now, the question is, where is this answer on the list? Well, this is a common thing that the AP people will do on your AP calculus exams. They will change up the numbers and they'll modify them so what you get doesn't show up in the answer list. You're going to second guess it. You're going to think you did something wrong. No, they're just trying to trick you. So let's look at our answer list right here. 1/8 is clearly not the same as 1/2. But what about 3/16? So 3/16, what if we just multiply the numerator by 2, then we get 3, and then we multiply the denominator by 2, that's 16. So 1/2 is equal to 3/16. So one way you can check for fractional equivalency, aka to see if a over b is equal to p over q, is you're going to make a equal to p. And the way you're going to do that is, let's say you have a is 2 and p is 6. You're going to multiply a by whatever you need to get a equal to p. So multiply that by 3. And whatever you do on the top of a fraction, you got to do it on the bottom, because if we multiply the top and the bottom by 3, what are we doing? We're multiplying by 1. We're not changing any numbers. So 6. And then whatever is on the bottom. So what I did right here, if I take 1.5 and I want it to equal to 3, I multiply that by 2. So 3 over 8. But I got to multiply the bottom by 2 too. So 3 over 16, that's my answer, B. Okay, let's take a quick look at this next problem. So we have a graph, piecewise function, and it's shown in the graph above, the graph of f. So the graph, we know it has a vertical tangent line at x equals -2. Basically, all that means is that the graph is vertical at x equals -2. And it has horizontal tangent lines at x equals -3 and x equals -1. What that means is that at x equals -3 and x equals 1, it's flat, derivative is 0. So it wants to know what are the values of x on this graph from x equals -4 to x equals 3, not including the ends, at which f is continuous but not differentiable. So let's just break this down. What does continuous mean? That means that the limit from the left is the same as the limit from the right. There's no gap, no discontinuity. So if we look at this graph, there's only one spot where it's not continuous. This graph, you can trace the whole thing, and from the left and the right, it's exactly the same, except for that one discontinuity at the origin at x equals 0. As you can see, if you approach from the left, you get this circle, and if you approach from the right, you get the filled in one. That's the discontinuity. So where is f continuous? All but x equals 0. So we already narrowed down our answers. Where is f continuous? It can't be at x equals 0. So any answer that has x equals 0 is wrong. We have two of them here. B, which is wrong clearly, and D, which is wrong clearly. because x is not continuous at x equals 0. Now, what about not differentiable? So differentiable basically just means you can take a derivative at that point. What kinds of things can't you take the derivative of? Well, if you have like a corner or a discontinuity, or if the graph is straight up, there's no derivative, so you can't differentiate it. So at like a corner, like we have a corner at x equals 1, there's no derivative. And at x equals -2, we have a vertical tangent line as it goes straight up, no derivative. So f is continuous at -2 and 1, but it's not differentiable. So does that tell us the answer? Are there any other points where it's not differentiable? Nope. So in this case, the points at which f is continuous and not differentiable are x equals -2 and x equals to 1. So that's answer is C. All right, now let's take a look at this one. This is like a differential equation of a slope field. So a slope field basically is a graph of the slopes at different points. So you can think of this as dy dx is a slope, and it has a different value at every x value and every y value. So how can we figure out what dy dx is? Well, in order to figure out what dy dx is, for example, if dy dx is 0, the slope at that point is 0, so we just draw a horizontal line. If dy dx is 10, then we draw a vertical line. Not vertical, but close, slanted up. So in order to find dy dx at a given point, we need to plug in the values of x and y. So if the function is dy dx equals xy, then the slope at any point is x times y. So the slope at 1, 1 will be 1. The slope at 5, 0 will be 0. The slope at 2, 4 will be 8. And the slope at 0, 0 will be 0. All I did was I plugged in the x and y values into this function, and I got the differentiable, dy dx. That's just the slope at that point. So if we look at this graph, it wants us to figure out which differential equation below does the dy dx fit this slope field. So if we look at the slope field, it's pretty simple. There are two places where the slope is going to be 0. So at x equals 0 and any y value, we can say, okay, the slope there is going to be 0. No matter what y is, if x equals 0, then the dy dx equals to 0. So for that to be true, every term in the function has to be either multiplied by x, or there has to be no y term that stands alone. So for example, if we had dy dx equals xy plus y, even if x is 0, y could still be positive. So at points of x equals 0, the slope would just be y. But in this case, no matter what y is, at x equals 0, slope is 0. dy dx is 0. So we have to look at our answers and say, okay, at which point where x equals 0 does dy dx equal 0? So the first one, we have xy plus x. So on that one, clearly, if x equals 0, the answer will always be 0. On the next one, we have xy plus y. So if we change x to 0, y is not always going to be 0, so dy dx could be greater or less than 0 depending on what y is. So it can't be this one. But the next one, x isn't even involved. So this one is completely dependent on y. So if we want the function to always be 0 at x equals 0, it can't be this one because there's no x in it. And the next one, x plus 1 squared, well, when x equals 0, it's always just going to be 1. So that can't be the answer. So the only possible answer is the top one, A, dy dx equals xy plus x. There, at x equals 0, dy dx is always x equals 0. None of the other ones have that. So that verifies that A is the answer. All right, let's look at this problem. This is the second derivative problem using a graph. So shown is a graph of f double prime, and the curve is given by the equation f double prime equals x minus a squared times x minus d. And the graph of f has inflection points and wants to know which points of x are those inflection points. So what is an inflection point? So an inflection point is where the concavity of the graph changes from concave up or concave down to the other one. So what does that mean? Well, if I have a graph and I'm graphing like this part is concave down. This part is concave, this part is concave up, my bad. This part is concave down, and this part is concave up. That just means that the graph is like pointing up, that means concave up, or it's pointing down, that's concave down. So how do we know where the graph is concave up or concave down? Well, a graph is concave up when f double prime is greater than 0, and is concave down when f double prime is less than 0. So if we have any point on here where f double prime is equal to 0, then that can tell us that the graph is neither concave up or concave down. So would that be the inflection point? Maybe. The thing is, inflection point is only where the concavity changes from up to down or down to up. So regardless of if the graph goes from concave up to flat and then concave up again, that's not an inflection point. It has to go from concave up to concave down. In other words, the graph of f prime has to actually cross the x-axis. So at this point, point A, we have a point where f double prime equals to 0, but it's not an inflection point because f double prime doesn't cross the axis. F double prime is negative on both sides of that. In other words, on the left side, it's concave down, and on the right side, it's concave down. What about here? Well, here the derivative is 0. The derivative of f double prime. We don't care about that. Ignore any point where it's flat if it doesn't cross the x-axis. We don't care about the derivative, we care about where it crosses the x-axis. How about point D? Here it crosses the x-axis. On the left, it's less than 0, and on the right, it's more than 0. In other words, on the left, it's concave down, on the right, it's concave up. That's the inflection point. Therefore, the answer is D only. All right, I hope this was helpful.